Hello, my name is Ray, and I'm the Ray in the Ray Code. In this video, I'll be covering the builder design pattern, and I'll be using Python. I have put timestamps in the margin so you may navigate to the sections I hear most. My favorite is SWOT analysis. I have used other programming languages to cover this design pattern, and I have used this programming language across the other design patterns. Please like this video and leave a comment. You can find me on all the social media platforms, Facebook, X, and LinkedIn. Also visit theraycode.org and .com. Please search them out and become a theraycode.groupie. What is a builder design pattern? The builder pattern is a creational design pattern that separates the construction of complex object from its representation. It allows the same construction process to create different versions of an object. Instead of creating a large object with a complicated constructor full of parameters, the builder pattern constructs an object step by step. Short definition: builder creates complex objects step by step while separating object construction from object representation. How it works in Python. In Python, the builder pattern typically uses an abstract builder class or interface that defines construction steps. One or more concrete builder classes implementing those steps. A director that controls the order of construction. A product object that represents the final result. Python makes builder especially interesting because Python supports dynamic typing. Object can be assembled incrementally. Optional parameters can be difficult to manage in large constructors. Method chaining can create cleaner, more readable code. Why should Python developers study the builder design pattern? Reduces constructor complexity. Improves code readability. Supports multiple object configurations. Follows solid design principles. Creates cleaner and more maintainable Python applications. Summary: builder helps Python developers create complicated objects one step at a time, rather than using large constructors. Think of it as the following recipe. Same instructions, different final meals. UML ORM for the builder design pattern using Python. Participant builder declares the interface that defines each step required to construct a product. Separates object construction rules from the object's final implementation details. In Python, this is commonly implemented using the abstract base class ABC. The director calls its methods while the concrete builder supplies the implementation. Participant concrete builder implements the builder interface and performs the actual object construction steps. Encapsulates the logic required to create and assemble product components. In Python, it typically maintains a product instance and updates it dynamically. It receives requests from the director and returns the completed product. Participant director controls the sequence and order used to build a product object. Ensures the same construction process can create different product variations. In Python, it usually stores a builder reference and evokes build methods. It works with builder interfaces without depending on specific implementation. Participant product represents the complex object being assembled during the construction process. Stores all parts and data generated by the builder's steps. In Python, this may be a class whose attributes are assigned incrementally. It receives its completed state from the concrete builder. Summary: builder defines the steps required for the object creation. Concrete builder performs the action of constructing the object. Director controls the order in which the object is built. Product: the final completed object returned to the client. I hope you're enjoying this video. Be sure to like and comment. If you have an improvement I could use, let me know. Hello, my name is Ray and I'm the Ray in the Ray Code. Today I want to review the Builder Design Pattern as stated by the Game 4 in their book Design Patterns Element Reusable software. The Builder Pattern is a creational design pattern that separates the construction of a complex object from its representation. It creates objects step by step, allowing the same construction process to produce different object variations. I'll be using Python. We start with a product class. The product class represents a complex object that will be constructed by the builder pattern. It will store all the parts that are assembled during the building process and provide a method to display the complete result. We create an empty list to hold product parts. We init self. We have a method to add parts to a list. We display the completed part and print the heading. We loop through all parts and print current part. Now, let's create the builder class. The builder class declares the interface that defines construction steps required to build a product. Concrete Builder will implement these methods. We start with the abstract class support. We create the abstract builder class. We have abstract method build part A. We do the same with build part B, and we get the result. Now, let's focus our attention to a concrete builder. The concrete builder class implements the builder interface and performs the actual object construction process. It creates and assembles product components. We import the product class. The concrete builder inherits from the builder. We init the constructor method with self passed in. We build part A and add the CPU. Next, we build part B and add the memory component. We show the result, the completed object, and final product. Now, let's create the director class. The director class controls a sequence of construction steps. It uses the builder interface and does not depend on concrete implementation. The constructor receives builder and stores a reference. We define the construction process. Build first component. We run builder.run build part A. And build the second component, builder.build part B. I think we are ready to go to main for our demo. We import the concrete builder. We import the director. We create the concrete builder. We create the director object. We begin the construction process. We retrieve the complete product, and we are ready to display the complete product, and we get product contains CPU memory. My name is Ray, always code with a smile. SWOT analysis of the design pattern builder for the Python student. S. Strengths. Simplifies complex object creation. Builds complicated objects step by step with clearer and easier to understand code. Improves code maintainability. Separates construction logic from business logic, reducing future modification effort. Supports multiple product configurations. Creates different object versions using the same construction process. W. Weakness. Adds additional classes. Builder introduces more classes than direct object creation approaches. May increase code complexity. Small projects may not benefit from the extra structure. Can require additional setup time. Designing builders and products initially takes more development effort. O. Opportunities. Creates scalable Python applications. Supports growth when applications require more object variations. Encourages solid design principles. Promotes separation of responsibilities and reduces coupling. Supports reusable construction logic. Allows construction processes to be reused across multiple object types. T. Threats. Over-engineering simple applications. Simple objects may not justify using builders pattern structure. Poor builder design causes confusion. Unclear construction steps reduces readability and maintainability. Excessive abstraction reduces clarity. Too many layers may hide the abstraction's true behavior. Well, that was my video. Please give this video a like. I worked hard to create it. Leave a comment and find me on all my social media platforms. But most of all, tell a friend the Ray Code is awesome.